Hi, and welcome to Lesson 1.5, a problem-solving plan using models. So in mathematics and science especially, we use a ton of different models, usually based around mathematics to start, and depending, two-dimensional, three-dimensional, so on. But models are typically used in mathematics and our application of science to help us better understand a situation. Now, today, the type of models that we're looking at to help us better understand algebra are going to be verbal models, and in some cases, also algebraic models. So, in order to create verbal models, we first have to understand vocabulary related to our operations and expressions or equations. So the first box here is making sure that you understand certain words in mathematics indicate an operation. So there's certain verbal phrases or verb usage that helps us understand which operation we'll be using. So for addition, we could say something such as the sum of 6 and a number. So the expression would just be 6 plus x. Variable is a number, so you can use any variable when they say number, and sum tells us operation of addition. Another verbal phrase would be 8 more than a number. So that could be written as the expression y plus 8 or 8 plus y. 8 more than a number. A number plus 5 could be n plus 5 or 5 plus n. Remember, with addition, we can flip order. And a number increased by 7 would be x plus 7. So key words to look for addition would be sum, more than, plus, or increased by. Then for subtraction, we have a few different verbal phrases that are common. Something along the lines of the difference of 5 and a number. So difference meaning subtraction of 5 and a number. Now in subtraction, order matters. Because they said 5 and a number, 5 was first, number was second, so it was 5 minus our variable y. 4 less than a number. So that would be written as x minus 4, because the 4 is less than, meaning that's what we're taking away, so 4 less than a number. 7 minus a number, again, order matters in subtraction. It was 7 minus a number, so we'd have to do 7 taking away our variable, so 7 minus n. And a number decreased by 9 would be written as the expression, our variable minus 9. So for subtraction, our keywords, difference, less than, minus, or decreased by. For multiplication, we have a few terms here. So the first verbal phrase would be the product of 9 and a number. So product means multiplication, so we just write it as 9x. 10 times a number could just be written as 10n, and a number multiplied by 3 could be written as 3y. Remember, a number next to a variable means multiply. We don't necessarily need a symbol in between. If you added a multiplication symbol, that is fine. And then for division, we have two common phrases. We could say the quotient of a number and 4. Number and 4, number was first, so that's what's on top. So n over 4. And then 7 divided by a number. 7 would be on top, divided by the number on bottom. And remember, any fraction means division. So this next little piece here, again, is just making sense of the fact that we could be given phrases or sentences, and we might end up with an expression an equation, or an inequality. So the first phrase, the sum of 6 and a number. If there's no phrasing here that says is something or is less than, is greater than, we're just an expression. So in this case, the sum of 6 and a number is the expression 6 plus x. Then, when we add the word is always gives us the equal sign if it's on its own. So the sum of 6 and a number is 12. So that would be written as 6 plus x equals 12. And then if is paired with a less than, greater than, less than or equal, or greater than or equal, we have an inequality. So in this case, 7 times a number is less than 50. So our inequality would be 7 times the number, 7x, is less than 50. So in example 1, they give us our different verbal phrases, and they want us to write it as an algebraic expression, equation, or inequality. So looking at A, twice a number decreased by 6. No is or less than, greater than, so it's just an expression. Twice a number, 2x, decreased by 6 minus 6. In B, 4 less than a number is 10. So 4 less than a random number, so x minus 4, is equals 10. 3 more than the product of 5 and a number. So again, we know it's just an expression because it doesn't end with an is or less than or equal to. So 3 more than would be 3 plus the product of 5 and a number is 5x. So it'd be 3 plus 5x or 5x plus 3. In D, 2 less than the sum of 6 and a number. So now this is where we need to be careful because it's addition and subtraction, and we have an order of operations. So 2 less than the sum of. So if it says the sum of, that tells me it'll be in parentheses. So sum of, that of meaning in parentheses. So the 6 and the number are added in parentheses, and then it's the minus 2 at the end for the 2 less than. 12 decreased by the quotient of a number and 7 is more than 3. So I know at my ending, whatever I have will be more than 3. 12 decreased by, so that's going to be 12 minus, and then the quotient of a number and 7, quotient's division, so we'd have x over 7. So 12 minus x over 7 is greater than 3. In F, a number increased by the sum of 10 and the square of the number. So again, we're back to that sum of, so that part will be in parentheses. So a number increased by, so I have to start with x increased by the sum of, so in parentheses, 10 and the square of a number, so x squared plus 10 in parentheses. So our whole piece, x plus, in parentheses, 10 plus x squared, would read as a number increased by the sum of 10 and the square of the number. And then for G, we have 3 times the difference of a number and 7 is less than 9. So the difference of tells me that part will be in parentheses. So difference of a number and 7 is x minus 7 in parentheses. 3 times that, so on the outside of the parentheses, we have a 3, and that whole piece is less than 9. So just taking our verbal phrases and rewriting them as expressions, equations, or inequalities. And remember to use this table here to help you out with some of the vocabulary. Now, Once we've had the vocabulary established, we can start to apply this modeling idea to different scenarios or word problems. So when we're writing algebraic expressions, equations, or inequalities to represent real-life situations, that is simply called modeling. The expression, equation, or inequality is a mathematical model of the real-life situation. So we might call it a mathematical or algebraic model. It means the same thing. When you write a mathematical model, we suggest you do it in 3 steps. So they suggest first just writing out what we know in a verbal model or words. Second, assigning the labels to our different parts. And then third, writing the final algebraic mathematical model. So to show you those 3 steps, we're going to look at example 2. Example 2 says you and 3 friends are having a dim sum lunch at a Chinese restaurant, and it charges $2 per plate. Ordered lots of plates of wontons, egg rolls, and dumplings. The waiter gives you a bill for $25.20, and it included tax of $1.20. Use mental math to solve the equation of how many plates your group ordered. So the way we start is by taking this word problem and breaking it down to a verbal model. Well, what I know is if I take the cost per plate times the number of plates, so cost of my plates times the number of plates, should equal whatever that total amount was, so the bill minus the tax. Now, to assign my labels, I know the cost per plate was $2. My number of plates is what I'm trying to figure out, so my number of plates will be my variable. In this case, I used a p. The bill was $25.20, and the tax was $1.20. So now I can take my labels and replace the words with what they are valued at. So my algebraic model, cost per plate, 2 times number of plates, p. So 2 times p equals the bill, $25.20 minus the tax of $1.20. So then 2 times the number of plates equals $24. Divide by 2, and we ordered 12 plates of food. So p would equal 12, or 12 plates. Now, when we apply these models to problem solving, we add an extra 2 steps. So the first 3 steps are what we just saw. Write the verbal model, assign labels, then write our algebraic model. Then steps 4 and 5 are to solve the model, and then to check the answer to see if it's reasonable. The way we could check our answer 12 plates is I could take 12 and put it back into my algebraic model. Well, 2 times 12 is 24. 24 will equal 24, so it works. Now, example 3, we're going to put together this whole idea to look at this scenario of a jet. So a jet pilot is flying from LA to Chicago at a speed of 500 miles per hour. When the plane was 600 miles from Chicago, an air traffic controller tells the pilot that it will be 2 hours before the plane can get clearance to land. The pilot knows that at its present altitude and speed, the jet must be greater than 322 miles per hour, or the jet will stall. So part A says at what speed would the jet have to fly to arrive in Chicago in 2 hours? So I'm going to start with putting a verbal model together. Well, I know if I have my speed of the jet multiplied by the amount of time, that'll equal my total distance. So speed is what I'm trying to answer. At what speed? So speed was x. My time to Chicago was 2 hours, given to us right here, 2 hours before the plane gets its clearance. And our distance left was at 600 miles. So speed times time equals distance. So I'm going to replace my labels with their values. 2 times x equals 600. Divide both sides by 2, and x equals 300. So my speed was 300 miles per hour. Part B then is saying, is it reasonable for the pilot to fly directly to Chicago at the reduced speed from part A, or must he take some sort of other action? Well, this last line told us if we're going less than 322 miles per hour, we're going to stall. Right now, our scenario told us in that 2-hour frame, we would be going 300 miles per hour. So it's not reasonable to fly directly there at the 300 miles an hour. Our plane will stall, so our pilot would have to do something different, such as changing altitude, circling around, things like that. So in this case, it would not be reasonable to fly directly there at 300 miles an hour. Our plane will stall. So as you go through the process today, I'm not super concerned as far as the verbal models in great detail. You can write them nice and short like I did. Cost per plate times number of plates equals bill minus tax. The labels you should try to come up with, and again, solving the algebraic models. The solve and check, you should just check to see if your answer is reasonable, and once you come up with it, does it make sense based on the problem? But the biggest point of today's lesson and the most important pieces are these vocabulary pieces, verbal phrases that tie back to our operations and help us come up with the ability to model and solve different word scenarios.